Hey, it's Mr. Shrum, and I am walking through the classifying matter tutorial, and I'm going to go through the states of matter lesson activity with you today. And we're going to look at the states of matter simulation to observe the motion of atoms and molecules in each phase and what happens as they are heated. To begin the simulation, we're going to click the states option. You should see the element neon in its solid phase inside the container. Here we go. Basic, here's states. We're on neon, and it's in its solid form at the moment. Let's go back to the instructions. So, part A. Observe the movement of the neon molecules in the chamber, then, one at a time, select argon, oxygen, and water, and observe the movement of the atoms and molecules in the solid state. Do the same for the liquid and gas states. Identify each description of how the particles behave in a solid, liquid, or gas. Drag the tiles to the correct location. Each tile may be used more than once. So, okay, here we go. So we have neon, argon, oxygen, water, do the same for the liquid and the gas states. Okay, so these are all the solid states: neon, argon, oxygen, and then water. Here's the strangest of them all, for sure. We have, so there's solid neon, there's liquid neon, and there's gas. I think that'll be easier just to do argon in the solid state, argon in the liquid state. Okay, so that one's behaving a little differently than the neon did. Neon seems to be a little more clumped together. Well, never mind. Neon and argon are looking a little similar in the liquid state. And then the gas state, yeah. Freely moving, bouncing all over the place. How is neon in the gas state? Okay, yeah. So oxygen, solid, liquid, gas. So you see how oxygen gas, denoted usually by O2, is because you have these pairs of oxygen, even in gas state. Then you have water in the solid form. Then you have liquid. And then you have gas, water vapor. Okay, so we saw that the solids had a very rigid structure. They stick together. Gases move freely around the entire container. Solids vibrated in place. They definitely stayed at the bottom. Liquids moved around, generally stayed at the bottom. Stick together. They stuck together for the most part. We'll see, move from place to place. Move from place to place. All right, I think that is all of them. Good. Okay. So the particles of a solid vibrate in place. They have energy, but they're just vibrating. They're not moving around like the others. And they are firmly connected to the surrounding particles. As a result of these strong connections, the particles form a rigid structure on the bottom of the container. And then the particles of a liquid stick to each other, but they're still able to move around, breaking connections and then making new ones. So they're not as rigid as those solid ones, but they still remain at the bottom of the container. They can't freely move around like gases can. And then the particles of gas, they don't stick to each other. They're free to go around the entire container. Then we have this. Now we have specific instructions to follow. So select solid and neon, and then we're going to use the temperature control to heat the neon to a temperature of 100 Kelvin. To increase the heat, move the slider upward, hold it there until the desired temperature is reached. Describe what happens to the neon particles as they are heated. So neon, solid. We're going to heat it up. So you got to hold it. All right, you see some of the particles breaking apart. They're moving around way more. Yeah, we'll just turn all the way up until we get to 100 Kelvin. And now it's starting to look a lot like a gas. Let's see what happens when you start to cool it. Now they're slowing down, bunching up together, and reversing the process, essentially. So as the neon is heated, the particles vibrate faster and more collisions take place. When the particles begin to break their connections with one another, the neon turns into a liquid. With more heat, the particles move even faster, and neon becomes a gas. So if you heat up a substance, the particles in the substance move faster. This causes more collisions to occur. It gives the particles the ability to break free, becoming a liquid first, and then, as more heat is added, a gas. So now we're going to do it with solid and oxygen. We're going to do the same thing, heat it up to 100 Kelvin, compare the behavior of the oxygen particles and neon particles at the same temperature. So oxygen, solid, heat it up. So we're even slightly above 100, and yet they're still sticking together for the most part. Okay, let's bring it back down to 100. Solid, and then So they're still bunched up way more than the neon was at this temperature. They both they both move faster, but oxygen appears to be mostly solid. Oh, sorry. I guess oxygen was more liquidy. There we go. So, yeah, I mean, I should have known. It's they're sticking together, but they're obviously moving more freely than in the solid state. So, it's a liquid. And particles of different substances have different amounts of attraction to each other. So the oxygen particles attract each other more strongly than the neon particles. Particles of both substances gain energy and speed up when they are heated. After being heated at 100 Kelvin, oxygen is a liquid, but neon is a gas because its particles don't stick together as strongly. All right. So that's the lesson activity for that section. We're still talking about states of matter, solids, liquids, gases, changes in state. A video. Oxygen and nitrogen, both normally found as gases in the atmosphere. They can be either liquids or gases. Other states of matter, we mostly talk about solids, gases, liquids, but we have plasma and the Bose-Einstein condensate, or BEC. Plasma is a gas that has been heated to such an extreme temperature that the electrons have been stripped away from the atoms. Stars are made of plasma, making it the most common form of matter in the universe. However, it's very rare here on Earth. It is frequently created by natural processes like lightning. Plasma can also be created by humans and is present in fluorescent lamps while they are producing light. Now, on the other hand, we have the Bose-Einstein condensate, and that is when temperatures are very low. Plasma is when it's very hot. BEC is very low, cold temperatures. The atoms of a Bose-Einstein condensate act as a single particle. The state of matter was created by scientists in a lab in 1995. The low temperatures required for the state don't exist in nature. So we get more definitions and dragging descriptions, or grabbing the appropriate word to each description. Substances and mixtures. This is how we organize matter. Pure substances are either elements, the most basic form, or compounds, a combination of these basic forms. If something is not pure, like these, then they are described as mixtures, and they can be homogeneous or homogeneous, and then heterogeneous. And here are more descriptions and pairing the texts. And a good way to remember homogeneous and then heterogeneous mixtures. Sugar, thoroughly dissolved in water. If you could reverse that process, it is heterogeneous. However, once you dissolve sugar in the water, it's very hard to get that sugar back out of the water. So if something dissolves or disappears in a substance, then it is a homogeneous mixture. Whereas a cloud, which consists of small water droplets distributed throughout the air, I would say a better example of heterogeneous mixture is a salad. Okay. So you can throw pieces of a salad together in a bowl, but you can also pick those pieces out after you mixed them together. Homogeneous mixtures like coffee, you can't take things back out once you mix them, or it's a lot harder to, at least. But that's the end of the classifying matter tutorial and lesson activity. If you have any more questions, let me know. Send me a message in Canvas, and I will help you out as soon as possible. But until next time, have a good one, and I will see you later.